Hello, I'm Paul Evans, P. Evans on CPAN. I'm doing a talk on Devel updated. So what I'm going to be talking about, first of all, what is Devel I'm going to try and keep that a bit brief because the overview of the main part of the talk really is what I've added in the past 4 years. I did a talk, not in this room, in the main theatre 4 years ago about this new exciting tool that I built called Devel and it looked kind of shiny and exciting at the time, and I sat and rewatched that video. It actually, it's improved a lot in 4 years, so I thought I'll do an update on some of the newer exciting bits. I'm going to include a bit of a use case demo of here is it finding a real bug in practice, because we've been using it for a lot of production stuff lately. That's where a lot of this has come from. So my little overview of Devel really. Well, MAT stands for the Memory Analysis Tool. It's an acronym I totally stole off Java because there's a tool for Java called JMAT. So I just stole the name. What it is if you imagine, probably a lot of people might be familiar with Devel NYT Prof, which is a tool for profiling CPU usage. If NYT Prof answers the question, where's my CPU going, then MAT really answers, where's my memory going? It kind of answers the sort of the counterpart question of, you know, this program might be fast or slow or whatever, but it's using more memory than I think, or there is some kind of memory bug with it. How do I find that? Well, Devel is probably the way. And similar to NYT Prof, it works in the same sort of way in that you record a file on disk in the process that has the problem, and then later on you use some tooling to analyze that file and understand what's going on. Similar to NYT Prof, where you kind of run the tool and it generates lots of HTML pages and graphs and things. Well, we have this sort of more interactive tooling here because with NYT Prof, it's quite simple. You can just say, where's all the CPU time going? And you can see time where or where not. But memory is a much more complicated question because things in memory might be large or small, but often a lot of the things that are large are kind of legitimately large. They were supposed to be there. And a lot of the bugs are sometimes not so much because things are large or small, but you have references where you shouldn't, or vice versa. And so the questions are a lot more subtle. You need a lot more advanced interactive tooling to be able to find your problems. And that's really where a lot of the emphasis has been. So just a quick overview. These are now slides from 2013. So I'll just briefly explain. Devel comes in two parts. There's the dumper part, which you run inside the process you're instrumenting. Writes the contents of memory to a file. Later on, you run the actual Devel tool set on it to analyze that. And I have this nice little animation where we run the dumper, it writes the file on disk, traditionally called something .pmat, just because why not. And then later on, we analyze it with some tools. And in 2013, we had a bunch of these little command line tools. So I'm not going to go into detail on the thing, but what you have is a single command line tool. You load the file, it loads up the file, it answers this kind of single question, prints something, then exits. We have this other tool, Identify, which you load the tool with, again, your heap dump file, and you pass in an address. It does some analysis. It prints out an analysis of, in this case, tries to identify where that SV comes from, prints that, and then exits. Turns out that's a little bit annoyingly inefficient because you're constantly loading the file, which could take several minutes, analyzing it just for one answer, and then exiting again. It's not very nice. I also had this GTK Explorer, where you basically have this fancy little UI, and it shows you a list of all the SVs and shows you things referenced from them or other things that reference into them, and you can kind of bounce backwards and forwards and look at them. But it's very much just a case of wandering around the memory you encounter. Whereas all of the actual analysis tools that do a lot of computation were separate command line things that you would just run, answer the question, and exit. So it turned out that this combination of tools wasn't actually very convenient to use. So in the past 4 years, I have done a lot of things. Primarily, I have added a shell, like a proper interactive command shell, which I just called PMAT, because hey, why not? Also integrated that shell into the GTK Explorer, so that everything you can do from the command line shell, you can also do from the Explorer, because that's where all the powerful tools are good. I've also just added a bunch of tooling and stuff. A lot of the existing tools I've extended and improved quite a bit. And it made it a bit more efficient as well. I mentioned in the talk 4 years ago where I had a file that took 3 seconds to generate and then 3 hours to load on my laptop. Well, there's been a lot of efficiency, a lot of rewriting stuff from Perl into C, a lot of subtle algorithm improvements to a lot of the analysis. There's a lot of stuff that's done even more lazily now, so rather than performing all the analysis when you load the file, it will often pause a bit and say, hold on a minute, let me do some more calculation before I answer that question. But it means that you can start using it a lot quicker. So the main core of the fancy thing I've added is this shell. So rather than loading the file off disk, running one little bit of analysis, loading the file again to do another one, we just load the file once into memory, and we have this sort of REPL shell type thing. So we just run pmat on some file, and we get this little shell. And so here I just typed help to just give a brief demonstration of the kinds of commands that exist. And we get the shell back, so we can just carry on doing more things in it. That load saves a lot of time. For example, we can just list all the symbols, because that's a little command line tool that I wouldn't have bothered writing before, because why would you load the thing on the command line just to print the symbols and then exit when you could just look at it in the GTK Explorer? Well, suddenly, now from the shell, because it's a long-running interactive thing, it's a bit more useful to be able to actually just see the symbols and things. So we can list symbols. We can list the values of a hash and whatever. And we have these little bits of syntax highlighting to just make it a bit easier to read. We'll see more examples of that in a bit. We have the shell in the GTK Explorer, which turns out to be really handy. Because once again, you've loaded the GTK Explorer, you've loaded the file. Sometimes loading these memory dumps can eat a lot of memory on the machine when you're analyzing it. So it would be nice not to use all that memory twice in 2 different Perl processes. So given we've loaded it into the GTK Explorer, we might as well have the shell. So we have this new fancy little area here and a little command line, and we can type commands in there. So for example, we can just run the symbols command again. And we get this nice little output. And what's nice with the GTK Explorer is that a lot of the output is a little bit more interactive than just printing stuff in a terminal. Because, for example, every time we print an SV reference, an SV address, these are actually clickable links. So rather than my having to retype this address in the command line to do something with it, I can just click on one of those, and it just jumps straight to the thing. It's also integrated in the other direction, in that if I am already looking at a particular SV, a particular bit of memory, then if I type a command down here, like identify, rather than needing to give an address to identify, it just goes, well, I need to know an SV to work on. You haven't told me one. I'll just take the one that you're looking at now. And that's really convenient as well. It just saves you, again, a lot of time having to retype the addresses all the time, copy, paste them or whatever. So that's quite exciting. I've added a whole lot more tooling as well. So the identify command is looking a lot nicer than it used to. So, ooh, the projector is throwing weird colors, but never mind. So first, see, there's color, which is very exciting because it's not so necessary on a small example like this. But when you have something that's 20, 30, 50 lines of output, just that dense wall of text, it just makes it just that little bit easier to see little things like the keys of hashes and symbol names and things if they have different colors. And again, on the GTK Explorer, all of these things become clickable links. So if you decide, oh, I wonder what that symbol is, you can just click on it and jump straight to it. So we have all this highlighting. We also have these little tree shapes here as well. It just helps you see the shape of it. Because if you have something a little bit bigger like that, you can see the tree structure a little bit nicer. And at some point I might get the GTK Explorer to actually draw that as a real in the scroller so that you can actually expand and collapse them. That's a lot of faff with GTK. I may get around to it, I may not. It also adds these nice little markers. Turns out quite a lot of the times you end up with these sort of cyclic references or at least multiple paths to the same thing. So here in particular is a little memory cycle, which it now kind of shows you a lot clearer by the fact that here's a thing which, by the way, I'm going to call A. So that when later on it gets to it, it says, well, actually, I've already seen that. That was A. So you can immediately look at this and see, aha, there's a cycle there. And if you had a much more complicated graph, you might get sort of A, B, C, D. It starts to go into double letters if it really runs out. But what else was I going to show? It also shows things like lexical variables in scopes and things so that you can see names of stuff. It just generally kind of helps you analyze a lot of stuff. There's the help command, which is very handy for, well, even for me, to be honest, to remind myself how these things work. But it makes a lot of things very discoverable. These nice little bits of syntax highlighting, again, just kind of help you. So you have this very discoverable help mechanism to find all the commands. And another command that I've added is this find command. So if, for example, you have an error message or some kind of string, and you know this string ought to appear in your program somewhere, but you're not quite sure where it is, you can use find PV, for example, to find it. And so here's an example. I was just looking to see the word greater than in this particular memory dump, and it turns out it only appears once. I thought it might have appeared more than that, but never mind, because this was a fairly large program, and it turned out only ever one place. And so again, that's a thing that would have been very hard otherwise with the GTK Explorer to try to find your string, whereas here you can just type it. And of course, that still works in the GTK Explorer as well. You can just type find PV whatever, print you an output, then you say, oh, there it is, click the link. You can find it straight away. So one of the things I didn't really do last year, well, 4 years ago, was given a scenario, kind of a real use case of here is it actually in use. So I thought I'd give, and this is a real scenario. This is this happened about 4 months ago, I think now, which prompted a lot of adding more tooling and stuff. So the scenario concerns a Perl process that's kind of a long-running server. It's growing in memory all the time. Your kind of fairly typical memory growth case. So what we want to do is find out what the bug is. So we arrange to capture the heap out of it by a fairly simple process. In this case, we can just run the binary with Perl and then pass in another module for it to load. Tell it to load Devel mat dumper, and we tell it to dump the heap if you receive sigquit. Because then it means we've not edited the source code here at all. All we've done is run it with another module. And so the program just happily runs and does its own thing. And then maybe a week or 2 weeks after, we decide, yeah, it's leaked a lot of memory by now. We want to see what's going on. So we just send it a sigquit, dumps the file. Then we can load the file. So we load the file, and it takes a long while to load. It takes absolutely ages to load, and eventually it loads. And it tells us some stuff. And so pretty typically, the first thing you want to do if you're trying to analyze why is this program using a lot of memory is you might want to ask it, well, what SVs in particular are using a lot of memory? What are the largest SVs? There's a command called largest. So much easier than loading it in the GTK Explorer, hitting the sort button to sort by size, and then scrolling down to the bottom. You just run this, it tells you what's biggest. And it turns out this bug was really easy to find because what we have here, the largest thing in memory is 1.6 gig. That is a single string that's 1.6 gig. The entire rest of the whole program here is, what's that, 46 meg plus 4 meg. So we're talking like maybe 55 or so meg for the entire rest of the program. That's a fairly clear winner there. That was a really easy one to find. But all we've got so far is this address. Well, how do we find out what that is? Well, we can run show on it, and we can say, what is that SV? Now, from the command line, you'd have to retype the address. But if you were using the GT Explorer, for example, you could just click on that link, and you would immediately jump to it. You wouldn't need to use the show command in GTK, for example, because it would show you all the stuff in the UI. But in this case, because we haven't got the Explorer, because I thought I would show the command line a lot more this time, we use show. And we can see, well, straight away, well, it's a string. It's 1.6 gig in size. It doesn't actually have any string contents to it, which is a bit of an interesting case. It turns out the Perl will make those a lot of times. For example, if the string ever once contained 1.6 gig of data, and you've since eaten prefixes off it with, say, a regex or substr or something, it won't ever shrink that buffer down. So what this means is we have subsequently deleted all the contents out of it, but it did once contain 1.6 gig. Well, how do we find out what that was? Well, the identify command. I showed you that before. And I thought I would just do this in 3 stages to show how the tree is built up. So I've limited it to a depth of 2 for now. And I've just said, well, what is this thing? Well, this thing turns out to be the key buffer of this object Mojo IO loop stream. and that thing itself is the value stream in some kind of hash. We didn't find what it was. Okay, fine. We'll jump forward a bit, and we'll say, well, to depth 4. Okay, that thing turned out to be this key in this hash, which itself was this key in this other hash. Okay, we're not really getting anywhere yet, so let's just really start jumping down. And now we suddenly get a lot of useful analysis where we can see, okay, so it was reachable as this sort of chain of hash keys from some object, and that object was $loop in, turns out, quite a few functions. Well, knowing our code, we know where all these pieces of code are. It's like, yes, I know where that object is, I can find that. And now knowing that object, we can look in the source code and we can say, well, what touches these keys and so on, and we can go off and we can find where that object turned up in memory. And it turned out basically this was a small bug in processing of incoming data. And that was a relatively easy one to fix. So there's sort of an example of how to use this. So moving on from here, I've still got a lot of things that would be nice to add to the tool set. Being able to type symbol names directly on that command line. So rather than having to look up what the symbol is and then type its address, I want to literally be able to type show $warnings, : offsets, or whatever. That would be nice. What would be really, really nice would be a kind of arbitrary expression thing where if you're looking at a hash, you could directly say, show me the 4th element of the array that's under the values key of this hash or whatever. It's possible to go a little bit too far with that sometimes because a lot of the analysis, there's lots of complicated cases, but some amount of useful command line structure might be useful there. I want a much better find command because at the moment all you can do is kind of find strings, and more or less every time I have a new bug, I end up adding another find option. So just generally adding more find options would be nice. And again, kind of Boolean options, because sometimes it'd be nice to say, find me all of the arrays that have exactly 5 elements that are blessed into this class where the 3rd element is a hash or something like that. Well, whatever. That kind of question would be really useful to ask. I want to add the reachability analysis, because that's another really useful thing where sometimes you end up with a lot of things in memory that have leaked because, for example, they might contain a memory cycle or something, and they're no longer reachable by the rest of your Perl program, but they're still sitting in memory somewhere. And often it's quite handy to be able to ask which bits of memory cannot now be reached by my program anymore, because those are definitely guaranteed to be bugs. So I want a command there. The concept of here, I want in the shell, because that'd be quite nice. So you can go kind of forwards and back, and just to avoid having to retype addresses all the time. It'd be very nice. And I've still got a lot of to-do list things from 4 years ago. I want to find cycles, CPU time on that. Like I have a cycle finder that again runs very, very, very slowly, and I need to find out kind of why and either re-implement it in C or do something else or something, because being able to find reference cycles is handy, but I haven't been able to provide it so far because it is so slow. And there's a bunch of other GTK visualization work to be able to draw things. And that's basically it. So you can find these things. It's the module Devel Mat on CPAN. I've also started writing the Devel Mat user guide, and people who know me might know that I'm kind of terrible at writing user guide documentation. So I very much encourage people to ask me questions in the form that I can then turn into scenarios and questions and answers and things in the user guide. That would be very handy. I did a talk, as I said, 4 years ago at LPW 2013. It's titled "Why Is All the RAM Gone?" That's on YouTube. Don't worry about the links for a moment. I've also been writing about Devel Mat on the binary.com tech blog, because that's where I'm working currently. Binary.com, they're a kind of stock market betting company, basically, but all of their internals are built on lots of Perl. There's lots of IO async there. There's some Redis. There's some quite exciting asynchronously type stuff. And they're hiring, so go and check that out. And go and do some cool stuff for them. And that's basically it. Thank you. And
about 20 seconds.
20 seconds for a question. Go on, really quick.
You want to pull outside?
I had a practice a couple of weeks ago where it turned out to be that something was deciding that every record that it was processing was an error was saving it on its processing object, intending to report on them at the end. But that's kind of millions of small records. Would you see that as the size of the array itself?
Well, there are multiple ways to count size. So, like, you can look at just the size of the array itself, in that literally this array is, maybe you've got, say, 6 pointers in the array, and that would just count as 6 pointers. Or you could say, what is the owning size of this array? So that's how big is the array plus everything that it uniquely holds a reference to.
That would be a good tutorial.
Yes. Yeah, there's another size that's even more useful to calculate, that's even harder CPU-wise to calculate, so I've not implemented that one yet, which is annoying, but yeah, that one would be good. Maybe let's do one more. Go on. Hello.
Well, what happens if your Perl process forks a lot?
In what sense? I mean, after the fork, you've now just got 2 independent processes, right?
Yes, so suppose you have some sort of forking server that forks off a process every time it needs to do some work. Would you end up with thousands of Devel maps, output files that all need analysis?
Well, no. So the question was what to do about processes that fork, and do you end up with lots of files? No, Devel map isn't going to write anything. It's not like NYT-prof that's constantly writing a journal. This thing just sits around kind of dormant in memory doing nothing until you poke it to say, write me a snapshot of what's in memory. So you tell it, write a dump now, and it just pauses for a moment, writes out a snapshot of everything that's in memory to the file, and then you can go off and analyze it later.
Right.
So that wouldn't really interact with fork. But I think we're basically out of time there now, so I'm going to say thank you again. And we'll call it there.